now, but we're going to go over these questions. So if you know the answer, raise your hand. I will call on you. And I'd like as many people to participate as possible so we could get through this and then get to the blood glucose story. What is carbohydrates made of? Anastasia.
It is made of carbon, hydrogen, and water.
Very good. And carbon, hydrogen, and oxygen, but if we combine the hydrogen and oxygen together, it would be water. So yes, we have carbohydrates. And I just wanted to mention, guys, if your mic isn't working, try to get a working mic because after midpoint of this semester, we do a lot of group work and you have to do a presentation. So I'll pause here to tell you, if you need to borrow laptops or any equipment, the Triton Library is loaning those out this semester, so you could contact the library if you think you need an upgrade for your computer because your mic's not working, or if you need a Wi-Fi hotspot, they do loan those out as well. And you could contact the Triton Library, just call up the school and they'll transfer you for your equipment. But I was in a lot of groups and many of the people weren't talking. For the rest of this review, if you would like to answer the question but you don't have a mic, raise your hand and you could type it in the chat room. Talia.
Yeah, can you hear me now?
Yeah.
Yeah, for some reason when we went to the group, I got that signal that kind of shows you that the signal is down. Like, you know how it shows those different bars? I'm not sure why, because it works fine now. Yeah, when we went to the group, no one could hear me.
You know, that's what happened to me at the beginning of class too. I wonder if it's just a poor signal today. Because when I logged in, I started talking and I noticed my mic wasn't working, and now luckily it is. Okay, guys, it must just be something with the system today, but hopefully now that we're back in the group, you guys could talk. Let's go to the next question. What is the function of carbohydrates? And that really answers why we have to eat it.
To give us energy. It's our daily.
Very good. Yep, very good. I think it was Journey. Good job. Was that Journey? I saw two people.
I'm sorry, I forgot to raise my hand. That's my bad.
No. But I saw two people's mic on, so I didn't know who answered. That gives us energy. And I did hear one of the groups talking about our muscles will use a combination of fat and carbs for energy. The higher the intensity of the activity, the more we rely on the carbs. And then our brains and central nervous system will only use the carbs. How many calories in 1 gram of a carbohydrate?
4.
Correct.
4.
Correct. All right, and what percentage of our diet should be carbs? Of all the food you eat in one day, how much of that should be carbohydrates? Anastasia?
60%.
Right, around 60%, you know, plus or minus 10, you'll be good. And then we get to the types of carbs. So, you know, there's two types of carbs. Who could explain the 2 types of carbohydrates, or at least name them? And if you need help with the explanation, we get someone else to help out. Yusuf. And I'm not sure if he's typing in the chat room maybe, or if he's going to talk. Your mic is showing. Now it's not. The mic isn't working. Okay, he's asking me to share the file. On my screen, I have it as being shared. You should see this handout on your screen right now. The 2 types are simple and complex, Yusuf stated. I'm going to go then onto my next part of the question. What is the difference between simple and complex?
The sugar, the monosaccharides and the disaccharides for the simple, and the polysaccharides for the complex.
That is correct. Yes. Does anyone know the simplest form of sugar? The simplest carbohydrate. Glucose is correct, Melissa. Very good. So we have mono and disaccharides being simple. We have polysaccharides being complex. And the primary difference between the two types of simple or complex is how quickly we could break those down and get them into the bloodstream, and how quickly basically they're going to give it, how quickly it takes to get energy out of them and how long the energy will last. So does anybody want to explain how quickly we get energy out of simple carbs and how long that lasts, and compare that to how quickly we get energy out of complex carbs and how long that lasts? Talia, you had your hand up first, and then I'll go to Journey. You could both speak.
Yeah, I was thinking with the simple, I would assume that it reaches the bloodstream faster or gets in our system faster, because when I juice like apples and fruits and vegetables, it kind of takes effect quickly. Whereas when I eat oatmeal, I feel like I digest it slower. Is that?
Yep.
Okay.
That is very accurate. That is very accurate. Journey, before I explain more, did you want to participate?
Yeah, I agree with Talea that simple carbs, they reach your system faster. And I think, do they last longer than complex carbs energy-wise?
The complex carbs will last longer.
Ah, okay.
Yeah.
Because you digest
The
it slower.
simple carb. Well, let me give you the whole class, a kind of example of, let's say we ate 100 grams of simple carbs. As soon as you eat it, all 100 grams are in your bloodstream. We either need to use that up with an activity or it gets stored. And that's the blood glucose story. Say we have 100 grams of complex carbs. It trickles into the bloodstream. A couple of carbs at a time will go in. We can use those up. Probably don't even need to store them because we're only getting like 2, 3 at a moment. So we don't have to worry about storage because they're going in so slowly. We can use it up right away with activities. Does that make sense? And I'm kind of just trying to give you a brief example of how they would differentiate. When we talk about the blood glucose story, I think it'll make a lot of sense. And also, there's a couple videos I'll show you as well. But those are the differences. Simple gets in quick, but only lasts a short period of time. Use it or store it. Complex goes in very slowly, lasts long periods of time. Like that oatmeal will give you energy for 2, 3 hours. Sometimes I eat oatmeal for breakfast. I don't feel hungry until like 4 hours later. Ironically, if I eat a bowl of cereal, which could be a whole grain, but the milk is simple carbs, and there's probably sugar in most cereals, which is a simple carb. So the breakfast cereal does have a lot of simple carbs in it. Honestly, I feel hungry within 1 to 2 hours. I feel like I need to eat again. And that's because that glucose is cleared out. I either used it or it was stored, as opposed to the oatmeal, which is just trickling in a little bit at a time. I use a little bit, gone. I use a little bit, gone. Okay. All right. The fun question now. Michael, did you have a question?
Yeah, I have a question because I was literally just drinking milk when you said that. So milk is considered a carb?
Yes, it is. We were getting to that question of examples in carbs, but any dairy product has simple carbohydrates in it. It does have that lactose in it. So it is a simple carb.
I thought it would be considered like a lipid or fat.
Well, let me tell you this, Michael, that's a good point. A lot of foods have multiple nutrients. It's not just isolated carbs. So I personally think milk is a great thing because it has all 3 macronutrients and it has micronutrients. But milk does have carbohydrates, which happen to be simple. It has protein and it has fat. Plus, it's got vitamins and minerals. So don't think that a food only has one type of nutrient in it. Okay? Most foods have multiple nutrients. All right? And dairy is one that actually has all 3. Now, if I picked on oatmeal, oatmeal has mostly carbohydrate, like 90%, 95% of the composition of oatmeal is a carbohydrate. It does have a small amount of protein and a very small amount of fat. Okay. But you'll learn as we talk about foods what has, what the food is made of, especially when we do the ingredient list and food groups. But a lot of foods are combos. Okay. So
Okay.
let's get some more examples. And I'll ask the class this. You guys could type in the chat room or just say it out loud, but I would like most of you to participate on this question. What kind of foods have you guys eaten in the last couple of days that had simple carbs in them? So Michael could have said milk. What else might it be? What are some other examples?
I had a bad food. Jolly Ranchers gummies, because I found out they're vegan and they don't contain gelatin. So I had some.
Okay.
A lot of sugar.
So you got that sucrose. Journey has cereal. Cereal most likely is a combination of simple and complex. If we read the ingredient list, if it had wheat or corn, that would hopefully be complex, unless it said wheat flour or corn flour. Then that flour part is what's making it a processed carb. But most cereals do have sugar. Milk is simple. Cheesecake, simple. Cake pop, simple. We have rice, cornbread, and white rice, French toast, pretzels. Those are all processed grains. Cookies, processed grains. Yogurt, Melissa has yogurt. That is a simple carb. Let me talk a minute about, a lot of people are putting like bread, rice. Ice cream is a simple carb, right? Because that is sugar and dairy. Fries, potatoes are actually complex carbohydrates. But what happens with French fries is when they're frying it, a lot of that oil gets sucked up into it. And that's why it might be considered kind of more like a junk food. Is it depends on how much oil that is soaking up into that potato. So you're going to get a lot of calories in French fries, but it's not necessarily from the complex carbs. It's from the fat or the oil that it's being fried in. You could bake your fries. I cut potatoes up, put them in the oven and roast them. And I cut them in what would look like a little piece of French fry shape. And my kids love it. They actually like it more than fast food French fries. That's just what they're used to. But that's a difference between, should I get French fries at a fast food restaurant or can I make it at home? And it's such a drastic difference between the health content of those two. Maple syrup is a simple carb that has the sucrose in it. Yeah. Grits or polenta, complex or a grain. I'm going to get to the differences between a whole grain and a processed grain in a minute. Nobody mentioned one type of simple carb that is a healthy version.
Fructose.
Fruit. Remember that fruit has simple carbs. The sugar in a fruit is a simple carb. Now, fruit does have fiber as well. Fiber, always remember fiber is a complex carbohydrate. But if we know that a food like fruit has a lot of different nutrients in it, we know it has sugar, it has fructose, that's a simple carb. It also has fiber, and then it has a ton of vitamins and minerals. So if I say, like, give me an example of food with simple carbs in it, I'm looking for a dairy food, I'm looking for fruit, or anything made with sugar. Those are primarily your simple carbs, okay? We will get to the difference between a whole grain and a processed grain in a minute. But as a quick preview, grains, if we pick them off the plant and we eat them the way they look, are complex. If they're processed, if we process a grain, it acts just like a simple carbohydrate. So it might as well be just sugar. Yeah. So if we're doing white rice, white bread, it's the same as a simple carbohydrate. Anastasia, did you have a question?
I just had a really quick question.
Yeah.
I know dairy is a simple carb, but what about dairy alternatives like almond milk, oat milk. Since I'm lactose intolerant, I drink like oat milk or coconut milk. Would it be a complex or simple?
I'm grabbing one right now. I bought almond milk. I just want to quickly read the ingredients before I comment here. So what it's saying in this almond milk that I have, let me see if I can share my screen, guys. My video. Trying to see if I can share my video, if it'll let me or not. It's trying. All right, I got Almond Breeze almond milk from Blue Diamond. The ingredients are almond milk, sugar, calcium, salt, potassium. This has 7 grams of added sugar. There is some simple carbs in it just because they added the sugar. And the almonds in themselves really are a combination of protein and fat. But they do have added sugar in the brand that I have. So check your label. There could be added sugar in the milk, and that would be simple. But if it doesn't have added sugar, it really should be a combination more of protein and fat, and obviously water. Okay? That was a good question. What are some complex carbohydrates that you guys eat? And I promise I will get to the difference between whole grains and processed grains in a moment. What are some complex carbohydrates you guys eat? Potatoes, yes. Beans, yes. Vegetables, yes. You guys are good on this one. Very, very good. Quinoa, yes. And what I'm looking for in this question is any kind of whole grain or vegetable or anything with fiber in it. Okay, so brown rice, yes. Whole grains could be brown rice, quinoa, whole wheat, oats, wild rice, barley, and then any vegetable. And the fiber content in fruit is whole grain. Excuse me, the fiber content in fruit is complex. So I know, is it Melina or Melina? She had mentioned banana. So banana would be mostly simple carbohydrate, but the fiber's complex carbohydrate. Talea, I'm not sure about that bread, but if it's made from a whole grain and it wasn't processed, then it would be considered complex. I want to show you my image of the grains now. I'm going to have to share my screen to get that. I think you guys are doing good with differentiating between what's a simple carb and what's a simple carb and what. Give me 1 second. My computer is catching up here. What do you see now? Do you see on my screen my PowerPoint? There we go. Do you see my PowerPoint? Yes? Somebody talk to me.
Yes, we do. Whole grains PowerPoint.
Yeah, so here's your whole grain. So this whole grain has 3 parts, right? Bran, germ, endosperm. As long as it maintains all 3 parts, that's considered a complex carb. It's going to have that trickle effect, give you a little bit of energy every few minutes, and this energy will last a very long period of time. Even if we crush it up or grind it up, as long as all 3 parts are intact, which is why we could make breads, pastas out of a whole grain. We crush the whole thing up and we use the whole grain. But what happens during processed grain is they take the bran and germ and throw it away, and they only use the flour. And then they make things with that flour, like bakery, bagels, rice, Fruit Loops, flour tortillas. They will make stuff with that flour. And when it is a processed grain, and only the flour is remaining, the bran and germ are gone. If it is a processed grain with only the flour, it acts just like a simple carbohydrate. So it gives you a large burst of energy for a very short period of time. You have to either use that up right away with activity or you have to store it. And that is the main difference between a whole grain and a processed grain. So I encourage you to try to get 1 or more servings of whole grains per day. All right. We talk about 60% of our diet being carbs. Most of that should be complex, which is vegetables and whole grains with a few fruit thrown in there too. Okay. And those are the healthiest options for carbohydrates: vegetables, grains, and fruits. A little bit of dairy is fine, but here are some options for whole grains. And then I have another slide that says what is not a whole grain. Anything that says the word flour on the ingredient list is not a whole grain. It's just the endosperm or just the flour. Okay, and typically it'll say enriched wheat flour, enriched or refined flour, refined corn flour, refined wheat flour. They do a lot of wheat in the United States. All right, so those are our processed grains, and obviously anything with bakery, cakes. I'm staring at a piece of cake right now that my kid made yesterday. Frostings, candies, that's all processed grains. Okay, who has questions about the grains? We watched that video about it last time. I'm just going to quickly check the chat room because I thought I heard something. Somebody got a question?
Notice on the not whole grains, it have farina.
Yeah.
So like cream of wheat, that's not a whole. That's not a That's not a.
From what I understand, it's a processed grain.
Wow.
Yeah. So if we made, not that you can never eat it again. Don't ever let anyone, and I will never do this, tell you you can't eat your favorite food ever again, whatever that favorite food may be. But we have to make sure that most of our food, like 80%, starts being from the healthier version. So here's the thing. If you want to continue eating, and I can't remember if you said farina, is that what you were mentioning?
Yeah, I noticed it's like the main ingredient on my cream of wheat is it's like it says wheat farina.
Yeah. So if you want to eat something like that, and that's your favorite, let's just say it is, add something with fiber to it. Add some fruit to it. Add some nuts, seeds to it. And now what you're doing is you're making it a whole lot healthier because that fiber, the presence of fiber will slow down how quickly the glucose gets into your bloodstream. And we're getting to that next here. But as long as you're eating something with fiber, it's going to benefit you, even if it is a simple carb. Okay? So it's not that you can never eat that again. Same thing, I told you the story about the pasta. We eat pasta. When we do, I try to add vegetables with it. So there might be vegetables added to it or on the side so that we have that fiber around to slow down how quickly we get the energy. So we are going to talk about this blood glucose story now. And before I do, any other questions about the differences between whole grains or processed grains? Okay, so what I'm going to do, I'm going to tell you the blood glucose story, and I'm going to tell it to you several times between today and next week. So don't get nervous if at first it becomes too much. This is being recorded. I will also share a video with you on this. But I am going to draw a blood vessel. And this could be any kind of blood vessel. And what we have is when we eat any type of carbohydrate, that carbohydrate will turn to glucose. Simple carbs turn to glucose immediately. Complex carbs turn to glucose over a span of a couple of hours. Once that turns to glucose, it enters your bloodstream. So here on your screen, you have a picture of a blood vessel. You have a picture of a blood vessel, and these G's are glucose. Okay, and that's glucose in your bloodstream. Now, the amount of glucose we can have, to be healthy, we're going to have about 80 parts of glucose. It's deciliter per milliliter of blood. That's the units they use to measure it. 80 deciliters per milliliter of blood is the low end of your blood glucose, and 120 is the high end. So as long as our blood has between 80 and 120 parts of blood glucose, we are healthy and we are safe. The glucose in your bloodstream feeds your brain. So we need to keep it maintained between 80 and 120, okay? And we're going to be healthy and happy as long as it's between 80 and 120. Now, what ends up happening is we eat, right? And depending on what we eat and how much of it we eat, we will have changes in blood glucose. In the morning when we wake up after sleeping and fasting for a long period of time, maybe you slept for like, maybe you slept for like, 12 hours or something, 10 hours. When we wake up in the morning, our blood glucose is probably fairly low, maybe 70, 80, 90. It's pretty low. The first time you eat breakfast, your blood glucose will increase. So after a fast, our blood glucose is low, and then we eat something. Depending on what we eat will dictate how quickly we have an increase in blood glucose. If we eat all simple carbohydrates or processed grains, our blood glucose goes up very fast and very quickly. Maybe we eat Fruit Loops with milk, and we have some pancakes made with processed grains, just white flour, with maple syrup on them. Our blood glucose is going to go from 70 to probably about 180 real quick. Now, it's not healthy to be above 120. So what happens is we have a hormone that will regulate blood glucose. We have two hormones that regulate blood glucose. The first one is called insulin. When we are above 120 parts of glucose, insulin, which is a hormone, will pick up the extra glucose out of the bloodstream, okay? And it's going to put any glucose above 120 into storage. And we can store it in three sites. We can store it in the liver or the muscle, and we call that glycogen. The liver and the muscle, we're not going to call the stored glucose that goes into the liver or the stored glucose that goes in the muscle, we call it glycogen. So we have muscle glycogen. That's the energy your muscles use for activities, is muscle glycogen. Now, if your muscle and liver are completely full, and they're like contained boxes, think of them like suitcases or gasoline tanks. If they fill up and there's no more room, then we have to store the extra blood glucose in the third site, which is body fat, adipose tissue. So these are the three storage sites for glucose if we go over 120 and we have to put it in a storage site. Liver glycogen, muscle glycogen, fat, which is adipose tissue. So what I want to tell you at this point is it is normal to go over 120 at your 3 meals per day, breakfast, lunch, and dinner. You should go over 120 slightly, because that's how your muscles will get their glycogen they need for activity. And what ends up happening is, let me see if I can use another color. Let's say this little orange thing up here is a muscle. And I fill that up with glycogen, okay? When I exercise, that gets cleared out. And so the next meal I eat, I have room in my muscle to put more glucose in it. So this is the benefit of exercising every day. If we don't exercise, our muscle glycogen stores are full and there's no room for more glucose to go into it, and I have to turn it to body fat. So you could run this system and not put on any body fat as long as you keep clearing out your muscle glycogen every day. We go for a walk, we do our chores, we're using muscle glycogen. Next meal, we fill it back up. We play basketball, we go dancing, we use our muscle glycogen. Our muscles empty of it, next meal, we can put the glucose back in. Problems start occurring is when we're not clearing out this muscle glycogen and there's no more room. Maybe your muscle's small, maybe you're not exercising, the meals you're eating will be going in as body fat, okay? This is half the story. The other half the story is, all right, so we eat let me draw in black here. We eat our breakfast, we go over 120. We start dipping. We eat a snack, bump up a tiny bit. We eat lunch. And let's say we have to go a long time without eating dinner and we actually go below 80. We don't want to be below 80 because remember, blood glucose feeds your brain. If you go too low, below 80, your brain cells will start dying. You could faint. You could run into a medical emergency. So if we're below 80, what will happen is we have another hormone called glucagon. I'll circle my hormones. Glucagon does the exact opposite of insulin. When we're below 80, what glucagon will do is it will look in your storage sites, any three of them, fat, muscle, glycogen, liver glycogen, and it will try to get glucose to put it back into the bloodstream so you don't die. You don't want to faint. So glucagon takes out stored glucose, puts it into the bloodstream, which is the complete opposite of insulin. Insulin puts glucose into storage, glycogen takes it out of storage. And this is really how the blood glucose system will work. And we could think of a few examples. If we're only eating, I'm going to go with purple now. If we're only eating, let's say, a really healthy diet, we eat breakfast, lunch, dinner, couple snacks. We wake up in the morning, say we're 70. Uh-oh. We wake up in the morning, we're about 70. We eat a healthy breakfast, maybe oatmeal, piece of fruit, go a little bit above 120. Insulin will store that hopefully in your muscle if you've been active and worked out the next day. We go back, say we're about 100. We eat a little snack. We eat our lunch, goes a little bit above 120. Insulin works to put that back into storage, a snack, dinner, and we go to sleep. This would be what would be considered a healthy diet. We go over 120 slightly, a couple times a day, 3 times a day. We work insulin only for a short period of time. Insulin takes about an hour and a half to bring the extra glucose into storage and have your system back between 80 and 120 after a meal. Okay. That little bump after each meal is called postprandial blood glucose. And it's okay to have a little bump after each meal. Now, we could contrast that to maybe somebody who is eating simple carbs all day long. You can come up with any different type of food plan that you may think of. I'll say, let's say we get up in the morning, we have a large coffee and a lot of sugar in it. Okay, we're going to get up at 70 blood glucose and we go pretty high. Let's say this person likes to drink soda or likes to drink juices that are full of sucrose, or they're snacking all day. There are people that stay above 120 all day, and that insulin has to work all day long. Liver glycogen, muscle glycogen could be filled up. We start putting on body fat. Okay, so we don't get fat class just from eating fat. It's really the calories. And in a lot of cases, it is simple carbs and processed flours, processed grains. What ends up happening is if you're over this 120 mark all day long, insulin gets tired and it starts wearing out. And it could lead to prediabetes type 2 or type 2 diabetes if we're constantly over 120 and we're wearing out our insulin. All right, 2 problems with constantly being over 120. 1, we're going to put on body fat. 2, we're going to wear out our insulin. So it really is dictated, the blood glucose is really dictated by how much you eat and what kind of food you're eating. If you eat anything with fiber, you're going to have a very slow rise. It might even look something like that. If you eat foods without fiber, you're going to shoot well above 120 right away. So always remember, if we want to have a slow rise of blood glucose and we want to have a steady stream of blood glucose between 80 and 120 all day long, we're going to want to eat a lot of foods with fiber. Fiber will slow down how quickly your blood glucose rises. And if we examine carbohydrate foods, fiber is in whole grains, vegetables, and fruit. Foods that lack fiber, which are going to bump you up over 120 are foods that are high in processed grains, which is flours and any kind of sugar, anything made with sugar. The biggest thing is soda or juices. That really bumps people up quickly. There's no fiber present, and it's all simple carbs. I am going to take a break from talking. What are your questions? And I know this screen looks crazy right now, but hopefully you followed along. You can view it again in the recording. I do have a couple videos for you guys. What are your questions? So if it's dead silent, that either means you don't know or you know everything. Which one is it?
I think I'm going to have to review it again.
Yeah, you know what? I am going to say this multiple times, and I'm going to cue you guys with some questions to make sure you can understand it. Because the blood glucose story, it really dictates one of the largest components of why we weigh what we weigh right now. But it also is so important when we talk about diabetes. So, Talea, did you have another question, or do you want me to review it again? Anybody?
Yeah, could you do it one more time?
Here is
Sorry.
frozen. Hello?
Say it again. Let me see if I can clear that. There we go. Clear it out. I'm going to be simplistic as I can here, okay, guys? You can hear me, right? Oh, her computer froze. Are you guys okay now? Are you guys okay?
Yeah, can you hear me?
Yeah. All right. Hopefully you
It's
can
saying
hear.
that it says I have a bad signal again. That's so weird.
Yeah, sorry. This is not a good day for that. Yeah. I can hear you guys.
No, I just think it's interesting learning about the glycogen and different things. I do notice I usually in the mornings I juice like 4 green apples, a stalk of celery, some lemon,
Yeah.
ginger, maybe a little bit of
Mhm.
pineapple. And
Mhm.
for some reason though, when I drink it, I'll get tired. But I've been tested several times. I don't have diabetes. It's just I think maybe I drink it too fast.
Well, actually, what you're drinking, as long as there's fiber in what you're drinking, I would say it's safe. Some people do juice and they take that fibrous pulp out. And that's really setting yourself up to put in sucrose, but no fiber, which is the complex part of it. So we want to keep the fibers in. So if we're juicing, I encourage you to use the whole thing. It sounds like you are.
Okay. Yeah, because I noticed I take all the fiber is pretty much removed with I'm just getting the juice out of it. So maybe I should alternate between that and smoothies because I was told that I guess smoothies you keep the fiber.
Yeah, yeah. The smoothies will keep the fiber. Like I just have a plain old fashioned blender. It was like 20 bucks. I put the whole thing in there. Maybe you want to take a little apple seeds out or a little core, but you could put the actual, the peel in with it. The whole piece of ginger. Anastasia said it lowers blood glucose. Then you would be getting the fiber with it. What I can say is when insulin is present and working, we do feel tired. And that's why after a large meal, we get sleepy. We can know insulin's doing its job. Insulin is working at this point in time. I know when my kids do like this macaroni and cheese, if I were to eat any of it, I'd feel like I need to fall asleep as soon as I got done eating. What that means is insulin in my body is working kind of overtime to clear out the blood glucose that I just ate because it's a processed carb. It's a processed grain. So the processed grain will act just like a simple carbohydrate. And it's just, here's our blood glucose, right? If we ate mac and cheese, we're probably normal's 120, 80 to 120. If we're eating mac and cheese, some of you can eat the whole box. I know my 10-year-old could. I'm going to go way up here. I'm going to go up to like 140, 150 after macaroni and cheese. And what happens then is when I go way up above 120 parts of glucose, insulin has to take that extra glucose and put it in storage. liver, muscle, or fat. Okay. Now, if I chose to eat a whole grain pasta with some vegetables in it, or a soup, minestrone soup has a ton of vegetables, okay, or beans in it, maybe just a different choice of food, my blood glucose only goes like this, maybe up a little bit over 120, but not much. And I don't want you to try not to go over 120, otherwise your muscles would never get energy. We do have to get energy into our muscles. That's why insulin is in our body to work. It's a good thing. But we can't be up in this area all day long, well above 120 all day long. Okay. And as I draw, let me draw my muscle here. We'll draw a yellow muscle. We'll draw a muscle. Gastrocnemius is always my favorite muscle. So what happens is I put glycogen in this muscle, and then when I exercise, I use this for exercise. I use this muscle glycogen for exercise. It empties out of the muscle, and every meal I eat after I exercise, I can store it as muscle glycogen instead of fat. So the benefit of exercising, number one, you get a bigger storage site because your muscle will get longer and wider. So you get a bigger site to put the glucose in. You can store more muscle glycogen. But also, then it clears out the muscle glycogen, and so every meal we eat could be stored as muscle glycogen and not fat. So I can even ask you guys, the meals you guys ate today, and hopefully you ate, did you store it as muscle glycogen or fat? And do you know which one it was stored as? Okay. And the deciding factor, class, of whether your breakfast was stored in muscle glycogen or fat is really how active were you today or yesterday. If you guys went for a walk this morning, it would be in your muscle glycogen. If you exercised really hard yesterday, it would go in as muscle glycogen. If you have not exercised or didn't do much at all today, then breakfast, the extra glucose from breakfast might have gone in as body fat. So, and it doesn't take a lot of exercise. You know what I tell people? You know what I tell people to do if they really want to avoid body fat? After your meals, go for a 5 or 10 minute walk. And even you could do it in your house. It's terrible cold outside today. Go for a 5 or 10 minute walk after you eat breakfast, lunch, and dinner. So you're burning up some of that glucose and it doesn't have to go in storage. Somebody skated for 2 hours straight yesterday, it's probably going in as muscle glycogen. So Yusuf asked the question of why do some people not gain any weight? And that's a good question. We'll talk about metabolism. There's a lot of factors that go into our weight, or we can also say how quickly our metabolism is. Age and genetics are two of the big ones. Young people have a very, very fast metabolism. So it seems like when they eat, anytime the blood glucose goes pushed up over 120, their body is burning that off rather than storing it. That's a quick metabolism. The more active you are, the higher your metabolism is going to be. The more muscle mass you have, the higher your metabolism will be. And that's 24 hours a day. The more active you are, the higher your metabolism is 24 hours a day. So there are people who have a very fast metabolism based on genetics, based on age, based on their activity level. When they eat and it goes over 120, they're burning that off rather than storing it. But I can tell you, age is a very protective factor. As we start getting older, every decade, our metabolism slows down and people start putting on the body fat once they're in their 30s, 40s, 50s, compared to when they were in their teens and 20s. Some of it's genetics. We're going to talk about theories of weight control, and that will be in a few weeks. But that's really one of the issues, is how quick your metabolism is burning it. And some people have better ones than others. Any other questions? Those of you who haven't eaten today, how are you still alive? Your hormone glucagon went to your storage sites, and your hormone of glucagon took out stored glycogen or body fat, and it put it back into the bloodstream as glucose, so you're not dead. Now, what I can say is we can pull fat apart and turn it back into glucose, but it's a very slow process. It takes a long time. Which is why sometimes we see overweight people and they say, oh, I'm tired, I don't have energy. When you see someone with diabetes or somebody who might seem overweight and they feel like tired, they can't do anything, chances are they don't have muscle glycogen and they have a lot of body fat. So the amount of muscle glycogen you guys have really is based off of how active you are. The more active you are, the more bigger your muscles are, the more muscle glycogen you have. But if you're not active, your muscles might be very tiny, so you don't have much muscle glycogen. A healthy active adult should have about 45 minutes worth of muscle glycogen for activity. Somebody who's a couch potato, sedentary, maybe they only got 5 minutes worth of muscle glycogen stored up. They got a lot of fat, but it takes a long time and it goes really slow to change fat molecule back into glucose. So often, they're going to say they're too tired to exercise or they can't do high intensity activity. Because remember, high intensity activity can only be fueled by carbs, which is muscle glycogen. Let me give you another example. Let's say you guys are in decent shape and you decide you're going to go for a 2-mile run. Maybe longer than that. That'll take you longer. Let's say we're going to go for, what is that? A 5K, which is a little more than 3 miles. So you start running and you're feeling really good. And you're going at a very fast pace. So we're going pretty fast. We're not sprinting, but running at a good pace. That run at a higher intensity, you're going to rely mostly on muscle glycogen. Okay, so you're burning off muscle glycogen. You get to a point where a lot of your muscle glycogen is gone or it's all gone. We don't have carbs available to fuel high intensity. We have to rely on fat. So we can keep exercising, but we have to kick it down to a lower intensity because fat is slow and it takes longer to burn. So you can burn body fat with exercise, but we really can only do that with lower intensity exercise. So this person on their 5K, 5-mile run, towards the end of it, they may start slowing down a little bit just because of where their fuel is coming from. If they have muscle glycogen, they can go high intensity all day. Once the muscle glycogen is gone and we have to rely on fat, the intensity needs to drop. Or what some people do is this is when they take a drink of their sport drink, because sport drink has simple carbs in it. You drink your Gatorade after about a half-hour run, you drink your Gatorade. That's all simple carbs. You could go high intensity again. Okay, so what I'm trying to convey to you guys is you cannot really do high intensity with only body fat present. You have to have muscle glycogen. Another example, let's say you have somebody that is a friend of yours that is overweight, obese, and they want to burn body fat. What do we do? What do we do? So we want to burn body fat. I'm getting my colors here. Bloodstream. Here we have muscle. Here we have fat. So what do? We get them to start working out. They have glucose in their bloodstream that feeds your brain. And they're starting out hopefully with having had breakfast. So maybe we're at 100 level of glucose in the bloodstream and we start working out. And as long as blood glucose is stable, we're going to be able to pull out muscle glycogen for energy. What happens is after they run out of muscle glycogen, you're going to see kind of a dip. Okay? And you could do one of two things. This will happen maybe about 20 minutes for poorly trained people, about 40-45 minutes for highly trained people. You're going to run out of muscle glycogen. Keep working out past that point, but you have to go to lower intensity if you want to lose body fat. So after the 20-minute mark for somebody who's not in good shape, have them start walking. They're going to be able to use this body fat for fuel. That's going to fuel low intensity exercise. They're not going to be able to run or sprint anymore because their muscle glycogen is gone, but have them go a few more minutes, 10 minutes more of exercise to get rid of that body fat. If they're stopping exercise at 10 minutes, they're really not clearing out much body fat. Okay. What are your questions? Otherwise, I'll show you a video. Now my screen froze. Give me a minute to get my screen unfroze. Does somebody have a comment or question? Because my screen is froze. I can't really. Ugh. Okay, guys, I think I'm back. Can you hear me?
Yes.
Oh my gosh. Did I freeze and was talking to like nothing for a
No,
while?
we
Or
heard you.
okay. Let me show you guys this video. So it'll be a little bit prettier than my picture that I wrote, that I drew on the whiteboard. Let me show you a video about this. It's only about a 1-minute video too, so pay attention. 2-minute video about.
When food is ingested, it travels along the digestive tract, where it is broken down into its component nutrients in order to be absorbed into the bloodstream. One such nutrient is glucose, a simple sugar. Glucose gets absorbed by the stomach and intestines and then enters the bloodstream. It travels through the circulation to all body cells.
So let me pause this right here. You see the blood glucose in the bloodstream? If insulin is working, we could pull this glucose out and put it in storage sites. The first 2 storage sites are always liver and muscle. If there's room in liver and muscle, we're going to put the glucose in there. If the liver and muscle are totally filled up, then we go to body fat. Okay?
Once absorbed into the bloodstream, glucose circulates, causing the blood sugar level to rise. An increased level of blood sugar sends a signal to the pancreatic beta cells, which respond by secreting the hormone insulin into the circulation. Insulin is necessary for glucose to reach and be used by several important target tissues throughout the body. These include the liver, muscle, and adipose tissue. Insulin is necessary to keep blood glucose levels stable in the body. Glucose enters the cell through a process called facilitated diffusion.
So let me use these pictures to help explain it then. So, you've eaten your carbohydrates. Any kind of carbohydrate, complex or simple, will break down to glucose. The simple carbs, as well as the processed grains, will change into glucose very quickly. And it'll raise your blood glucose above 120 very quickly. We can use that up right away, or we're going to store it. The complex carbs trickles the glucose into the bloodstream slowly. So you will have a gradual rise of blood glucose, maybe not even going over 120, depending on how much you ate. So that really dictates how quickly the blood glucose rises. Complex, it'll rise slower. Simple or processed carbs, it will rise very fast. Then you see these insulin helping the glucose go into the storage sites. Okay. The glucose that gets into this muscle is called muscle glycogen. That's what you use. That's what your muscle uses when you exercise, is muscle glycogen. And we can think about it. Every time we exercise, we're clearing the muscle out. It becomes empty again. And we're making the muscle a little bit bigger. So the next time we eat, we can store the carbs in our muscle. If we're not exercising and this muscle can't take in any muscle glycogen, it goes to body fat. Here you see an image, and I like that at the end. It said energy. That glucose went into the muscle, and we can now use that for energy. If we use insulin all day long, or we eat one huge meal per day, but that's it, we're going to wear out insulin. It's going to get tired and it's going to stop working. And that's type 2 diabetes, is when it wears out and stops working. That is the blood glucose story. I have 2 minutes left of class. What I'm going to do, guys, is I'm going to email you another video to watch to help you remember what blood glucose story is. And I'm going to have you guys do 3 things for homework. The first two you already knew about. Tomorrow night, which is Friday night at 11:59, your carbohydrate discussion and your carbohydrate quiz are due. So you're going to go into Blackboard. I'll show you where it is. You're going to go into Blackboard. Yeah, you can see my screen now. You're going to click on Learning Modules, Learning Module 1, because we're in carbs. Once you're in Learning Module 1, you're going to see my notes, my PowerPoint, some videos that I've used. You're going to do the discussion, and you're going to do the quiz. Okay, you can do the quiz twice, higher score counts. If you want to check back to see if anybody commented to you or me on your discussion board, you could go directly to your discussions. You don't have to go through the learning module. And it looks like 4 or 5 people already did their discussion. Okay. So you're going to do your quiz. You're going to do your discussion on carbs. The third thing, well, actually, it's almost 4 things. I want you to watch the video I'm going to send you on an email. It's about 11-minute video about blood glucose. I want you to tell the blood glucose story to someone that you know. If you recall and retell this blood glucose story, it's going to help you remember it. And the way you're going to recite this story is, I wake up in the morning, my blood glucose is pretty low. Depending on what I eat will dictate how quickly my blood glucose rises. Between 80 and 120 is normal. If I eat foods with a lot of fiber and that are complex, I'll have a slow rise in blood glucose. If I eat simple carbs or processed grains, then I'm going to have a very quick rise in blood glucose. But once I go over 120 is when insulin starts putting the extra glucose over 120 into storage. There are 3 storage sites, and you could explain that. Once you get them into storage, talk about what happens if you're not eating and you've gone a long period of time. We're going to use glucagon to pull the storage sites and put glucose back into the bloodstream. So think of it this way. Insulin will lower blood glucose. That's over 120. Glucagon will increase blood glucose if it was less than 80. All right, I am going to stick around for questions. If you came in late, raise your hand for attendance. Otherwise, you guys are free to go.
Thank you. See you Tuesday.
Thank you. See you guys Tuesday. Have a good weekend. Odalis, I do have you now. Or Odie, I do have you. Bye-bye. Andres, I have you. Guadalupe, I did have you down for attendance already. Did you have a question?
No, it's because it took a while to connect, so I didn't know if you had me on there or not.
Yep.
Okay. Thank you.
Okay, bye everyone. Have a good weekend.